Activity 1.2 is called Amazing Algorithms, and just to give you a rundown of what Activity 1.2 consists of, you'll just follow along with this. First thing you'll notice is the essential question: what does effective teamwork look like? So a big part of Activity 1.2 deals with working with somebody else, collaborating. The materials that you will eventually need for this are the map printout and the bus cutout. Both are located typically in the back of the room. This just goes and just kind of sets the stage for what we're going to get into with the algorithms and then teamwork as well. Introduction to algorithms. Remember, every time you see a term that is in orange, you're just going to click on it and write that definition down. Take the time to watch the algorithmic thinking video. This video takes you through it. It does a really nice job of explaining how algorithms actually work as far as a step-by-step list used to complete a task of some sort. It could be planning a birthday party, it could be going about your normal business day or like a school day or something like that. And then it gets into flowchart. And a flowchart is not the same as an algorithm. It shows right here, it's a diagram that represents an algorithm. It shows the direction, it shows arrows, it shows symbols, and right here is an example of an algorithm. It starts off with an oval, that's the beginning point. The arrows connect each event. So it's not a numbered list like an algorithm is. These are going to use the symbols with your arrows to take you to the next spot. Please make sure you write this chart down in your notes, that you understand what the oval is, what it does, what the purpose is, the rectangle, and the arrow. When you get back to Activity 1.4, we're going to add an extra piece to this, but right now this is all we need to be aware of. This shows another flow chart. You should be able to figure this out pretty easily what happens. So here's the beginning part, what happens your first event, your second event, and so forth. Again, there's no numbers on the flow chart. This hide and seek activity, you can work on this with a partner. What you're going to do is you're basically going to take an item, you can use one of my highlighters or pencils, and go out to the hallway and hide it. And then you're going to write down all the steps that your partner would need to go out to the hallway and find it. So for instance, I might say, step number 1, go to the door. Step number 2, walk through the door frame, out to the hallway. Then I might say, turn left, walk so many steps, turn right. You're going to guide them to find it. So when you're at the hide and seek section, just come on back and I can give you the item that you can use. Do make sure that you understand how the hide and seek activity works first. We're not trying to make it impossible for someone to find. You're really working on the algorithm part of this. Couple of instructions here, read through those as well. Here's a reflection in your PLTW Gateway notebook. This is just getting you to stop and think about the activity you just did. For instance, we're able to find your assigned hidden object. Why or why not? Were the directions not clear? Was the algorithm not clear? How could you help improve your algorithm for next time? Next activity deals with navigation, and you will see that this map is in the back of the room with a little bus cut out right here as well. Your job, and it says with a partner, you can work on this with a partner, you could work on this by yourself if you want to, it's really up to you. It says create the algorithm using a flowchart or numbered list. So you're going to take the bus from the school all the way around to the museum. Now you can go this way, you can go up here, you can go down. Main thing is to work on is typing or writing out the commands. Now here are the navigation movements. Move forward. You'll notice the F is capitalized. So that's called camel case, which we've already learned about. Turn left, turn right. You will not see a move up or a move down. You will not see turn left times 3. You're only turning left once, and then you're moving forward after that. Right here it says, with this movement, the bus does not move forward or backward. It only turns 90 degrees in its place. So for instance, I'm going to put down move forward, move forward, move forward, move forward. A way to shorten that would be move forward times 4. And I'm actually physically going to take my little cutout and move it. Every time I move it, that is one of the commands that I'm going to write down in my notes. And then you can swap with another group if they're working about the same pace and same time as you. You can do that. Or you can just check with your partner. That works as well. You're then going to go down to the conclusion question, and then you're going to go into PowerSchool Learning to find the assignment. All right, thanks a lot.